So this m-sub is 1.4, which is in the 1.1 in the previous textbook. Okay, I'm going to use the, what's that? Okay. Now, in this section, we're going to discuss about tangent and velocity problem. What is tangent? In Korean, we say 접선. Okay, tangent means tangents. We say touching. So your given curve, you want to find the line we touch at one point. Okay, so touch. What's the mean touch? Just touch one point like this. This is called tangent in the graph, and then we can apply this one into a velocity problem in the in kind of some physical. We talk about physical problem. So you given distant function. So then you find some kind of tangent is like a velocity. Then you have to think about when you look at what's the speedometer? Okay, in the car, then your speedometer is always keep moving, right? Not still. There's no always moving, keep like this. Then what's the meaning of that one? We can think of this. That is like a velocity, some point. Okay. So in this case, think about a tangent problem. First, we discuss about tangent problem. So look at, you have some circle here. Say this circle touch, you have a line here, so touch one point. So this is called a tangent here. So just cross one point, right? Only one point. If you saw it's like this, then cross 2 points. Well, this is called tangent. Okay, in Korean, 접선, possibly you can say that. Suppose you have this curve like this, right? Then you want to find the tangent at this point. You draw a line through this point, but touch one point. But this can be possibly to cross this curve. But still, you can say that this tangent at this point. Okay, we want to look at what is the meaning of tangent. When you have a curve and line, we're going to discuss about that one. Suppose you want to find the equation of a tangent line to the parabola y equals x squared at the point 1.1. You know that what is graph of y equals x squared? If y equals x squared, you know that this is parabola. We say this is parabola. Okay, y equals x squared. It's called the parabola. So we know that x equals 1. You're going to have a y equals 1 here. Then you're going to have like this. So we want to find the tangent at this point. Okay, 1, 1. This is called x coordinate. We call this is a ordered pair. In Korean, 순서상. Okay, ordered. We have an order here, and there's pair, right? So we say ordered pair. You want to find the line through this point, just to touch one point at this one. So you want to find it like this, right there. I'm not a good artist. Okay, so like you can draw like this. This is we want to find equation of this line, and how to find it. Okay, question is like this: how to find it? Then what you have to do is to choose one point which is close to this one. So you can say that some point here. So this is arbitrary point. You can choose the point. Then this one's gonna be maybe possibly x and what? X squared, right? Because this is x coordinate, no x squared. Then connect these two lines we call line segment. So it's secant. Secant is line segment. So you cut 2 points and you have a line here. That is called secant. Okay, line segment. So you want to find suppose what is the line segment of this one? Then this line. So what you have? You're gonna have you have a line. How to find the equation of a line? This is done. How to find this equation line? You need what is that? 1 point maybe, right? 1 point at what? And what? Slope, right? Slope. Slope is in Korean. I'm gonna use some terminology because you're not used to English terminology, so I'm gonna speak some Korean when I introduce the terminology. This is called 기울기, right? So you need slope and also 1 point. 1 point is given here. So you need slope. How to find the slope? So we call slope of the secant line through these 2 points. So we say MPQ. PQ equal, how to find the slope? Say rate of this rate, x change from x to what? 1, right? This 2 point x and 1, this one, to find the slope. So you can, maybe you can draw like this. What is this length? This is x minus 1, right? What is this length? This is going to be x squared minus 1, like this. So this slope. Okay, so you can say that x squared minus 1. This is a slope of the line through these 2 points. Okay. Now, so this is too far from here, and now you can get close to peak, close to 1, then what happened? So you have a concept of a limit, okay? So this is a slope. Now if you can, of course, you can choose some point which close to this one, say 1.5, say 1.5. Then what is y? At that point, 1.5 here. What's going to be x? 2.25, isn't it, right? 1.5 square is 2.25. Then what is a slope of the line through this 2 point here? And what is that? M is going to be M, PQ, say this in this time, 1.5 minus 1, 2.25 minus 1, like this. So it's going to be 1.25, 0.5, which is 2.5, like this, right? 2.5. In this fashion, you can find some, say, you choose some point which is close to this one, like this, okay? So say like this. I'm not gonna, I don't know, this thing, the stupid things to calculate all of them, those like this, okay, like this. And then you choose this one. Then possibly a 2.5 here, okay? Now, actually we wanna write this. I didn't make like this, but I'm not trust this recording system, so I write down here. So we have 2.5. So try to get close Q into P like this. Then, if you know already how to calculate this limit, right? You know how to how to calculate this limit. Even though we're gonna do again, but when you calculate this one, limit x approach to 1, then you have x minus. So we say usually we will read numerator, denominator. Okay, numerator, denominator. So we say x squared minus 1 divided by x minus 1, like this. So try some number, pick up number which is close to this one. Then you may choose like a point starting with 2 and then 1.5, say 1.1, 1.01, something like that. You keep going this way, you'll see this one. I think this one has table, I guess. Oh, you didn't have it. I thought this one has 2.5. You choose. And now, let me use your knowledge. So actually you did this one, right? Like this, x plus 1. You factorize x minus 1 divided by x minus 1. You can x minus 1. X approach to 1 means x is not 1. Okay? So you can cancel out this one. So you have x approach to this. You're going to have a 2 like this. You have your slope here, right? Anyhow, we're going to learn the basic concept about how this limit properly working. Okay? So that like 2. So what is that? Then y, we have 1 point here, right? Slope is MPQ equal 2, and then we have 1 point, P equal 1 and 1. So it's going to y minus 1 equal 2, x minus 1. This is the line equation. So say y equal 2x, what's that? Minus 1. This is line equation, which is tangent of this curve at point 1.1. So we have like this. This is line equation. So this is tangent. We say this tangent. Tangent means line equation. We call tangent. Okay. Now, so this is the kind of procedure. So this one has nice. Here, say this is from the Q approach P from the right. Right. So right. So Q is right, and then so getting close to P. this is almost q to p here. I think this is a tangent. Explain about what is tangent. Okay, you can make this one q approach p from the left like this. Like this. In this case, from the q is in the left side, so getting close to p, then almost the same as like this. Okay. Numerically, I think this one has numerical things about. This is q approach p from the left. Now, look at the velocity problem, kind of. Say example 2. So, you know the flash unit in camera. Okay, so flash unit on camera operated by storing charge. Well, you know what is charge, right? Charge on a capacitor. What is capacitor? Capacitor? 축전기, right? Charge journey. Electricity. Capacitor and releasing it suddenly, and when flash is set up. So if you step flash your camera, you have a red light, right? So just push the button. It's gonna be, I don't know. The data table describes the charge Q remaining on the capacitor. When you what's that? How can I say that? Push the button, right? Then push that. Charge capacitor. Then we say that remaining in the capacitor measured in microcoulomb and time t measured in second after the flash go off. Okay, and then use the data to draw the graph of this function and estimate slope of tangent line at the point where t equal 0.04. In this case, it's not the function which we are talking about continuous case. This is discrete. We say discrete case. Sometimes you're going to have this kind of data. Okay, then you want to find the tangent. Then you can think about what is the meaning of tangent in this case. Okay, this case. So note that the slope of tangent line represents electric current flowing from capacitor to flash bulb, right? Another flash bulb. Flash bulb in the in micro. What's that? Now, so in this case, this is kind of table given data. Okay, so they check how much charge in capacitor in here. So t equal, when you push the button, it's gonna be 100. But after that, going down 0.02, like charge is 81.87, so on like this. So actually, you wanna find what's that? Rate of change of what's that? What's that? Charge at that time, okay, 0.04. So this is not the continuous function, which is like this. This is different from like this. Y equal x squared, we have like this. Then this is which doesn't matter which x value you choose, you can find the y, right? But in this case, only few points given there, right? Like 0.02, 0.04, 0.06, 0.08. But you want to find at this point. Okay, then what you have to do? You have to plot this point on the graph, okay? Then it will be like this. Like this, okay? So here, point, it's too far from here. Anyhow, 0 to 0, 1, x, t is 0. At time, this is 100. And then after 0.02 second, down to 81.87, right? And then after 0.02 second, that this one is going to be 67.03 and so on like this. So getting, everything is going like this. Then what is that? So we want to find change of rate. So in this case, we want to find tangent line here like this. Okay? How much change like this? Okay? So actually, we want to find the slope. So this is a curve connecting this curve point, right? Then it's going to be you have a red line. It's going to be curve here. So we want to find the point tangent at this point. But we given only 5 points, right? Only given 5 points. How to find in this case? Okay. Do you have any idea how to find this one? How to find the slope of this line over there? What you have to do, previously we said that you choose closed point, close to P, which is this point or this point, right? Right? Now what is the slope of these 2 points through this secant line? You draw secant line. So you can find the slope of this line equation through these 2 points. Okay? How to find it? then you can say that 0.04 minus 0.02. Actually, you have to say that 81.87 minus 67.03, right? Divided by 0.02 minus 0.04, like this. Okay? You can do this way. I think we have some kind of device pushed. I don't know. We don't have it. Now, so given point, say here 2 point. Suppose you get 2 point here, then you can make a slope, right? So numerator is a change of charge, and the denominator is change of time. Okay, then you have a minus because this is a down decreasing, so it's going to be minus. You're going to have it like this. Okay. So now using this kind of technique, you can find this table. Okay, what is this one? What this one stands for? Like this. R right here. Using this point and this point, okay, this one, then you're going to have this one, minus 824.25. So using these 2 points, you're going to have like this, okay? Using these 2 points, you're going to have this data. Keep going this way. This one is data given. This is kind of a slope of the secant line through 2 point, 0, 0, in this case, 0.000 and 0.004, like this, okay? Now, what is the closest point from 0.04? Only 2 points, right? So actually, you don't need these two. So when you look at this graph, this one is effective one, right? So you're going to use these 2 points. So this is slope. You have this slope, right? What is this one in this table? This one slope is like this, right? This one, right? And then you're going to use this slope. What is that? This one in table, like this. Then you add, divided by 2. It's going to average. So you have to choose average of this one. Then that will be most close to slope of this line. Okay? So we found this way. So it's going to be this one is not a little bit different, but we have to use that one. But this one stands for, in this case, think about, we're just guessing line through, this is a line here. Then you're guessing this point, much better, this one close, right? So you just use this 2 point and find the slope like this one, A, B, B, C. This is A, this is C. Then you want to find the slope of these 2 lines. It's like this, a 2 point, line through these 2 points, okay? So it's going to minus 670, like this. But best way is to use this 2 and divide by 2. This one, this one, this one, and this one, okay? You add and divide by 2, that's better. No. Make you wake up. Okay, that's the problem. Now you know what is the meaning of tangent when you talk about curve, right? Now, velocity problem. So, what is velocity? Suppose you have a ball is dropped from the upper observation deck on CN Tower, which is in Toronto. Is there anybody who went to Toronto? Have you been Toronto? No? If you go there, there's a nice, what's that? Kind of tower, building, which is, I've been twice over there, okay? Then if you go through, you can go, this is kind of transparent, what's that? I don't know how to explain it, that one. Anyhow, that Toronto tower is CN Tower from 450 meters above the ground, okay? You can see down there. And then find the velocity of the ball after 5 seconds. You dropped the ball over there. Look at see how long it's gonna take to hit the ground. Okay. But in here, we want to find the velocity of the ball after 5 seconds. Now, what's the meaning of the velocity after 5 seconds? Can you find the velocity at the specific point time? Is it possible? Do you think it's possible? You can find the average velocity. Suppose you start from Byungcheon. I want to go to Daejeon. Its distance is going to be maybe 60 kilometers, right? maybe. And then it took 30 minutes. Then what to say? What is the average velocity from here to Daejeon? Maybe, or how much is that? 30 minutes, 60 kilometers. You drive more than 120 kilometers, right? Right? Within 30 minutes, you go with about 60 kilometers, something like that. Now, what is the meaning in this case? What is the meaning of velocity? What is the meaning of velocity at 5 seconds? Okay, at the time when you drive with car, say 9 o'clock, then you see the speedometer say indicate 100 kilometers. How they calculate that one? Okay, think about this way. How car calculate speedometer at the time? Okay, this is kind of a velocity problem we're not talking about. Now in this case, this is CN Tower. It's nice. Nice scene here, right? So this is observation deck here. This is an observation deck here. Okay, I've been up to this point, not more than that one. Okay, if this is kind of glass here, transparent glass here. This is a lake. So 5 Great Lake in the U.S. and Canada, Michigan Hole, something like that, Michigan Lake, and something like that. I think this is called, I don't know which lake is this one. Anyhow, then with freely dropping, what's that? If you dropped, then you're going to have this kind of relation, right? ST, this is distance, 4.9 t square. So this is proportional to time square. We say this is 4.9 t square, ST is 4.9 t square. Then, same thing, 5 seconds. After 5 seconds, where is the position of this object, ball? You put 5 here, right? 4.5 times 5 square, it's going to position. We're talking about where is the ball is in there. Then at the time, what is the velocity? What you have to do, you have to choose close time, right? Around 5 seconds. Okay? You can choose the 4.9 second, or you can say that 5.1 second. 4.99, 4.999, something like that. Okay? You can make that one. So you have to find the average velocity, which is change in position and divided by time elapsed. Okay? How much time elapsed? Then it's gonna be so you can choose 2 points, which is 5.1 second. What is position? Okay, this S5 is position when t is 5. Then time elapsed is 0.1 second. So divided by like this. Then you're gonna have this calculation. I'm not gonna do this with this simple things, right? So like this, I say 49 meter per second. This is kind of we say the velocity at the time. Okay. Now you make a table. Say time to time interval. If you can make a time interval between 5 and 6, then you're gonna have average velocity is 53.9. Make close to 5, so like a 5.001. You see that 49.99, something like that. Then getting close to what? Close to where? 49. Close to 49, right? You can guess. It's gonna be 49 meter per second at the time. Okay? So you choose anyhow. You have to choose. Suppose you have a speed. What's that? What's called? I forgot that, how to spell. When you drive the car, some kind of speed. What's called that one? Speed checker. Huh? Huh? Speedometer is car. I mean, checking whether you're keeping specific speed like this. Camera. I'm sorry. Speed camera. Speed camera is correct. Camera, which checking whether you're driving proper speed, right? Like speed limit. You're checking that one. More than 10 kilometer, then you're gonna have a ticket, right? Maybe depend on how much over the what's that? What's that? Anyhow, something like that. So that they check. They have a tool line there. So they calculate time checking how fast you cross these 2 points. Okay. Then say this is 1 meter, right? Then checking time. Say you pass this 2 point like 0.01 second, right? 1 meter. That means you cross 1 second. How many meter? 10 meter, right? Then you just change the same minute and hour. Then you can have a speed, your car speed, right? Then they can check. That's the way working. Okay? They have two. If you look at carefully, then you have 2 lines there. They're checking the time cross these 2 lines. Okay? That's the camera is working, operating to check whether you're driving properly or not. Okay? Proper velocity. Okay? So now instant velocity when t equals 5 we define to be. So that's why we say that instantaneous velocity. We say velocity means instantaneous. Not average velocity means you have two time interval, right? But instantaneous velocity means at that point, 1 point. So you're looking at 1 point, which is tangent of the line. So 1 point, you want to checking velocity, okay? So define to be limiting value of this average velocity. So limiting x of t approach to 5.001. So t try to approach to 5, right? Or short and short time period, then at the time to start at 1. Now, so that's why we say in this case v equal instantaneous velocity is after 5 seconds is v equal 49 meter per second. Okay. If you draw this one, already we talked about this one previously with is that the secant line, the average velocity, this one instant velocity, right? So slope of the secant line is average velocity, and then this slope of tangent line is instantaneous velocity. But usually you say velocity means instantaneous velocity. Okay, you can omit this one. It's okay, no problem. Okay, this is 1.3. Now, oh, this is 1.4. Okay. This is end of section 1.4, which is we talk about tangent and velocity problem. Okay. Now, so you see that what kind of concept we need to talk about tangent and velocity? You need limiting process, right? What is the meaning of limit? So we're gonna study about limit to make this kind of tangent. To find tangent and velocity, you have to have a concept of a limit. Okay? That's why we're going to study a limit again, even though you study limit at high school, right? I think you did that one. Now, any question up to this point? It's okay? You guys follow me? Because I'm very nervous because the camera there. I mean, this is first time you see. Okay, always usually it's happening beginning of semester. Now, after finish this section, we're gonna have. Also, I mentioned. You have when you maple TA is like this. You go there. Your handphone number is a password, and ID is your session number. Okay, I set that way. I cannot demonstrate because this one the internet doesn't working. So you have to have HTTP mass. Okay, ID is a student number, password, your handphone number. You have to use slash, okay, 010/2234/1234 like this, okay? Then already I put assignment, first assignment, which have about 50 problem, maybe 45, maybe. So next Monday, you have to bring, you have to print out. First, what you have to do, first print out, and then solve, okay? And then bring Monday. So I'm gonna make some team. So I'm gonna give you a chance to talk each other. Okay. Like this. Okay. If you have any question, maybe you may have trouble with login, then you have to call me. Okay. You can use what's that? 카톡. Okay. But don't use nickname, okay? If you don't use your full name, I'm not gonna accept, okay? So if you use just like Jin, I'm not gonna put my on the list, okay? So you have to use a full name, okay? Full name. Full name, okay? Not nickname, okay? Any question about Maple TA? Also, I don't know. Anyhow, if you have any question to put in, I'm gonna put some manual into what's that? el.kroeatech.ac.kr over there. Okay. Now, don't forget, bring this one Monday. So I'm gonna make grouping so you can do practice on Monday. Also, you're not gonna have a class on next Thursday because I have to go somewhere formally. Okay. So no class on Thursday, next Thursday. Okay. And do you have let me ask, do you have any class after? Check your schedule. Do you have class at 10:30 to 11? Huh? Tuesday? Is anybody who has class? Tuesday, 10:30 to 11? Thursday? Because I'm going to use this time because we're going to be behind the class because I'm going to absent on Thursday. Okay. Is there anybody who has class Tuesday, Thursday? 10:30 to 11? Both day? Both? Which day? When? Which weekday? Huh? Tuesday? Both? Oh. Okay. Okay. No way I can make up that at the time. Anyhow, now let's start limit. Let's talk about limit of function. Already you used to do this kind of concept. I think you did in the high school. Okay.